are you, my friends? This is another pre-calculus challenging question where the graph of this function f of x, absolute value of 6 minus 2 to the power absolute value of x, and then minus 2 is below the x-axis. So we have to graph it first, then we see where the graph is below the x-axis. Please, for more pre-calculus challenging questions, PCQ, you can visit the playlist Pre-Calculus Challenging Questions. This is the given function. I will go here in details, please, so that the method will be easy on you. First, we graph the function inside. See, this is the function inside 6 minus 2 to the power absolute value of x. If we have a big absolute value on the function, we try to graph the function inside. After that, we reflect the negative part in the x-axis, which means we move it from below to above the x to be positive. And then at the end, we have a minus 2 shifting down after the absolute value. Now, I will go in details here, as I said. Let n of x be the inside function. So 6 minus 2 to the power absolute value of x will be n of x. That's a function here. So now we have the function f. This is the given. So the function f will be absolute value of n of x minus 2 is outside. So let's start now graphing n of x, 6 minus 2 to the power absolute value of x. We take two cases, as we said. Case number 1, where x is positive, x greater than 0. From algebra, we know that absolute value of x is equal to x only if x is positive. So now we have a function 6 minus 2 to the power x, simple exponential function. I will call this one b of x, b from the blue here. All right, so let's start here by the basic, base 2. So that's the increasing here. See, this is black dashed. And then there is a minus there. So that's a reflection in the x-axis here. You see that? And then we are shifting up 6 units. I put that one here. So this one, the blue one here, all this blue, including this one, this is b of x. But we need x greater than 0. X greater than 0 means here in quadrant 1, quadrant 4. So we take this blue part and we neglect the other one. So b of x will be only this part because x positive. Positive means to the right of y x's. This is x positive. Now what we'll do on the next slide, I will say case number 2. I will take x negative and draw some graph there. I will call it R. R means red. And then I will take the negative x, the part and the negative x, quadrant 2 and 3. Let's see that. Case number 2, the same function now, n of x. If x is less than 0, the absolute value from algebra of x will be minus x, remember. So now instead of absolute value, I put here minus x, only if x is negative. So let's call this function r of x, 6 minus 2 to the power minus x. So I start with the basic 2 to the power x. You see, this is 2 to the power x increasing. And then the minus on the line, it will be a reflection there in the x-axis. And this minus with the x will be the reflection on the y here. You see this one? Then we shift this graph up 6 units. So it will be the red one. While we have two different colors, this red where x is negative. X is negative means to the left of y axis. So we have this graph only that we need, this one we neglect. So this is r of x. Now we have to combine the red part. See, this is the red part where the negative x. Combine with the blue part. This is the blue part where the x is positive. So we can have this one in the middle. See, this is where x positive on the right. On the left where x negative, I combine them. So this is the n. N of x will be 6 minus 2 to the power absolute value of x. That is the graph. Now you cannot say this is parabola, guys. Some of you might say this is a parabola. It's not parabola. This part, the blue, is coming from the exponential, and this part red is coming from another exponential. So this is the graph of n of x. All right, now let's see. This is the n of x from the previous slide. Now reflect the negative part. If I need here absolute value of the n, see, this is the n here, the graph. Absolute value of the n means all the values should be positive. So whatever negative part I have here below the x, negative part, now below the x, negative y, I reflect that above the x, you see? So this graph is n of x, and this graph here, absolute value of n of x, which is absolute value of 6 minus 2 absolute value of x. Now what's left is the function f. Function to graph f, shift this function here, this graph, you see it, shift it down 2 units. So when you shift down the whole graph, see, this is now the whole graph, absolute value of n, shift it down 2 units, see, shift absolute value of n 2 units down, you get f. So that means, and in that case, we will have some x-intercept, and we have to find that on the next slide. So when you shift down the whole graph, look at this. This is the black. That's the final graph of the f that we need. So for sure here, we have to find the x-intercept. It's not good. It's not enough. It's not accurate to take it from the graph, because sometimes these are not integers or easy numbers. Okay, so to find x-intercept, let y equal 0 in the function f, in the original, this one here. So put this one is equal to 0. So I have absolute value minus 2 is equal to 0. Take 2 on the other side. So this is an equation, absolute value equation. So this in the inside here will be plus or minus 2. Rearrange it. I put here 2 to the power absolute value of x is equal 6 plus or minus 2. So I take here two cases, 6 plus 2, 6 minus 2. Now 6 plus 2 is 8. 8 is 2 cubed. Now we have the same base here, 2 and 2. So absolute value of x will be 3. Also, this is absolute value equation. So x will be plus or minus 3. This one, 6 minus 2 is 4. 2 squared. So absolute value of x will be 2 because we have the same base. So x will be plus or minus 2. So these are the 4 x-intercept. Now the question, where the graph is below the x. Look at the nice answer here. Below the x, from minus 3 to minus 2, open interval, union from 2 to 3. I know this is a long question, but it's nice and interesting. You can learn from it. You can take any part you like. Now, for more exponential graphs, please, you can visit the playlist, either pre-calculus, all the exams questions, graphing exponential functions, or pre-calculus course, lectures 2 and 3. Thank you for watching. If you like the video, you can subscribe and share it with your friend. I hope I can see you in another video with another pre-calculus challenging question. Thank you for listening.